So this question is to find the equivalent resistance. So we can redraw the circuit here. Basically, we can first assign the node. Here we assign as node A, and then we can assign this big node here as node B, and then this is node C, and then we have very big node here, okay, as node D. Okay, now we're going to redraw these circuits before so we find the equivalent resistance. We start from this positive terminal of the voltage source using the breakdown method. We have this positive voltage here, and then connected to this R1. This is our R1, and then now is this R1 N terminal is A0. Okay, that means here is our A0 here. Now A0, we need to see how many current path it can go. We have this one, and then here, and then going down. So there are 3 paths here, right? So this A0 is split into 3 current paths. Okay, so now for this resistor, which is the R2, right? And then R2 we split into another one is what we call as the R4. This is our R4, and from this R4 we have another one which is the R3 here. Okay, oops, where is this R3 here? Okay, this R3. Okay, so the N terminal of this R2 is the B node. Okay, so now here we have this B node here. So on this B node, what we can see here is split into this one, and this one. So we have a three path as well, from starting from the B node split into 3 paths. Okay, so here we have this R6, and then we have R7, and then we have now in this case here, okay, and this is split into this R8 and R9. So that means from here it's split into 2. Okay, split into 2 here, R8. Here we have this R9, right? Okay, now from this R6 and R7 is connected to the C node. So mean that R6 and 7 be connected together. And here is our C node here. From this C node, we have this R10. So here is R10, right? So at the R10 terminal over here is the D node. Okay, so let's say here is our D node here. Okay, so how about the N terminal of R8 and R7 also is connected to D node. So that means this R8 and R9, they will connect together and then directly go to the D node. Okay, now refer back to the last one, which is this R3 here. Now you see here, for this R4 is connect in series with R5. So that means this R4 and R5 here, we have one more resistor, which is the this is R5, okay? And then R5 connect to the N terminal of the R3. So that means these ones are connected together, and that these ones, you go to the D node here, okay? So this, at the end, this is our negative terminal. So from this, we can find the equivalent circuit. So in this case, what you can see here, we can calculate this. This one is in series, in the parallel circuit. That means R6 is parallel with R7. So we know that what is the R6 value? R6 value is 1 ohm. So here let me label this. Here is the 1 ohm, and R7 is 0.5. So that means it's 1 parallel with 0.5. So in that case, we get 1/3 equivalent resistance. Okay, and then we also can calculate this one as 1 parallel equivalent resistance, that is the R8 is parallel with R9. Okay, so the R8 value is 1 ohm and R9 is 2 ohm. So that means 1 parallel with 2. Okay, so that here we get 2 over 3. And then what else? We also can calculate this equivalent resistance here. You're going to replace with single resistor. So in this case, what we can see is this R4 is series with R5 and then parallel with R3, right? So R4, we're going to give the value for this R4 here is 0.5 and R5 also is 0.5 and R3 is 2 ohms. So in this case, we have this 0.5 by 0.5 to get 1 ohm. So this 1 ohm over here, okay, this 1 ohm is in parallel with R3 is 2 ohm. Okay, so that means this one is so same as 2 over 3. Okay, so from this, we can reduce this circuit. We draw this. Okay, so we draw this, we start from this positive terminal. And then we have this R1 and then connected to this anode here. Okay, so this anode is split into R2. Okay, and now we can replace this R4, R5, and R3 with a single resistor. And this single resistor is 2 over 3 value. Okay, it's this value, which is this value over here. Okay, and this one is the R2 value. What is the R2 value for this? This value, let me check. R2 here is 2 ohm, so this is 2 ohm. Okay, equal to 2 ohm. And then from here we have this B node. Okay, connected to this B node here. Now this B node here, we already simplify this with single resistor. Okay, this is the R6 and R7. This is 1 over 3 ohm. Then connected to the C node. And from this here, we also have one equivalent resistance with R8 and R9, which is 2 over 3, right? 2 over 3. 2 over 3. And then this C node here is connected to R10, okay? Connected to R10. So what is R10 value is 0.5. So this is 0.5. And then we have this D node. Okay, this is our D node here. So from here, this one is directly connected to D node. And this N terminal here also go to the D node here, right? Okay. Right, now we can further simplify this circuit here, this one. Okay, we can easily see this circuit. What is this circuit? That assume that this circuit, equivalent circuit, is recalculated as a resistance of B. So in this case, we can see that 1 over 3 is in series with 0.5. And then they are parallel with 2 over 3. That is RB. Can you count this RB? You get 0.3703. Okay, 3703. So from this, you can reduce the circuit now. Okay, let's say you redraw it one more time. Okay, here you have this R1. So connected to this split into 2. This R2 is 2 ohm, and then this one is already replaced with this RB, which is 0.3703. And then here we have this resistor here. This resistor is 2 over 3. And then connected to the D node. This is our negative here, right? Okay. So in this case, what is R1? We can see here R1 is 1 ohm. Okay, so we replace this value. This is 1 ohm. Okay, so now we can find the REQ value for this. REQ value for this is what? Is this 1 ohm resistor now is in series with this 2 and 0.3 are in series, right? 0.3703. And this in series is in parallel with 2 over 3 resistance, right? 2 over 3 resistance. Then by calculating this, you get 1.52 ohm, approximately 1.52. Okay, so the equivalent resistance across this circuit is 1.52